Hey everyone, today we're going to be talking about intermolecular forces. So you might be wondering, what are intermolecular forces? Well, inter means between. Therefore, intermolecular forces are forces that occur between two molecules. So there are two types of intermolecular forces we're going to be talking about today. The first one is London dispersion forces. So O2 is a nonpolar molecule, but it exists in a liquid state. So the question that scientists asked was how? How do nonpolar molecules like O2 attract each other when they don't have dipoles? Because there has to be some form of attraction for it to exist in a liquid state. And the answer to this was London dispersion forces. They explain how nonpolar molecules can have attractive forces and exist in a liquid form. And I abbreviated London dispersion forces here to LDFs. So, London dispersion forces are temporarily induced dipoles, and they're generated through collisions. So in these collisions, the electrons are pushed to one side of the molecule, generating a temporary dipole, and it was induced through this collision. This dipole makes one part of the molecule slightly positive and one part of the molecule slightly negative. And the slightly positive part will attract a slightly negative part of a different molecule and make them stick together, and this is what allows nonpolar molecules like O2 to exist in a liquid state. And these collisions have to happen frequently enough in order to keep the molecules together. So the first type of intermolecular forces are London dispersion forces, and we mainly see them with nonpolar molecules. The second type is more straightforward, and these are dipole-dipole interactions. So some molecules are naturally polar. Therefore, the slightly positive part of one molecule is attracted to the slightly negative part of another molecule. So it's like these London dispersion forces, except these dipoles are naturally there instead of being induced by a collision. You already have these slightly positive parts and these slightly negative parts. So that's pretty straightforward. Now we're going to go into a little subset of dipole-dipole interactions, which is hydrogen bonding. And this is an intermolecular force, not actual bonding. So it's the same as dipole-dipole interactions, except one of the atoms, usually the less electronegative one, is hydrogen. So this explains why water is a liquid at room temperature. Because let's think about it. Heavier molecules and elements like nitrogen, or N2, O2, and carbon dioxide, CO2, all weigh more than water. H2O weighs 18.02 grams per mole, while N2 weighs 28.02 grams per mole, O2 weighs 32.00 grams per mole, and carbon dioxide weighs 44.01 grams per mole. But these last three, nitrogen, oxygen, and carbon dioxide, are still gases despite the fact they are heavier. This is because hydrogen bonding does not work for them, but it does for water, which leads it to be a liquid at room temperature. So it causes the water molecules to stick together a little bit more because it's a little bit stronger than just dipole-dipole interactions, and that's why it's a liquid, while these other heavier molecules / elements are actually gases. So a little fun fact, hydrogen bonding is also what's responsible for holding DNA together. Because DNA is a double-stranded molecule, and it's held together by hydrogen bonds. So when those bonds are broken for replication or other biological processes, it's broken by breaking these hydrogen bonds. So helicase kind of unzips the molecules by breaking the hydrogen bonds. And these bonds are strong enough to hold our DNA together. So typically hydrogen bonding is the strongest, followed by dipole-dipole interactions, followed by London dispersion forces, which are the weakest. And this is just typically, there could be exceptions to this, but typically this is how it goes. Thank you so much for watching this video today. I hope you learned a lot about intermolecular forces, and specifically about these two types of intermolecular forces. So have a great day, and if you had any questions at all about anything I talked about in today's video, just comment below or email us at exceledlearning@gmail.com, and we would be happy to answer all of your questions. Thank you so much and have a great day.